Okay, so we're going to now try and factorize quadratics that look like this. Quadratics that have got a number in front of the x squared. At the beginning of this playlist, we did them where there was nothing in front of the x squared. This time I'm going to do them where they have 2 or 3 or some kind of number in front of it. This is higher only, of course, and this is much, much harder. So method 1 is careful guessing, but that's not always going to work for harder ones. Method 2 is to split the x term up, which I will describe in just a second. Now, careful guessing is to think to yourself, right, what am I going to need to put in these brackets that are going to make this work? Well, I know definitely that the beginning part, I'm going to get a 2x squared, is going to come from these two things. And the only way I can really get that is if one of them is an x and if one of them is a 2x. But you can't just put these 12 numbers, you can't just randomly think of two numbers for 12 that add to 11 because of this extra 2x that we've got here. So I'm going to just say what I think this one is going to be. I think that it's going to have to be over here, probably a, let me just quickly check, is that going to be a 6 or a 4? Yeah, this one is going to be a 4 over here and a 3 over here. Now what I was trying to do was think of how I could get the 11x, being careful that this one has a 2x, because the 2x and the 4 gives me an 8x, and the 3 and the x gives me a 3x. The 8x and the 3x together makes the 11x, and the 3 and the 4 makes the 12. So this careful guessing is not easy to do. You can see how it took me time, and my full-time job is teaching maths. Now I've expanded these brackets just to show you that it works. I get the 2x squared, I then get the 2x times the 4, that's 8x, the 3 times the x, which is 3x, and the 3 times the 4, which is 12. And of course, those bits goes to the 11. Now this is hard to do just by the guessing. So I wouldn't necessarily recommend this. Instead, what I would recommend is this idea where you can split the x term up, and then you do this other process that I will describe as well. So if they look like this form where there's a number at the beginning, we want to find two numbers, and this is how the method works, that multiply this time to give AC, that multiply to give these things multiplied together, but still add to this term. Now previously when A was 1, it would just multiply to give 1 times C, which is just C. So previously we were saying it multiplies to C, but actually it needs to multiply to AC and add to B. That's the two numbers we're going to look for. Then you split the bx up into those numbers and you factorize using the earlier technique. You know what, trying to describe this in words is much harder. It's going to be much better to just see it in practice. So we're going to do the same thing. We know what the answer is going to be, but we're going to do the other method, which is like a surefire method. So we are thinking of two numbers which multiply to AC. In this case, AC is going to be 24, and we want them to add to 11. So I need to find two numbers which multiply to 24, but add to 11. It's going to be 3 and 8. Look, 3 and 8 were these ones. That's actually what we're trying to do. We're trying to find those two numbers. So 3 and 8 multiply to 24, and they add to 11. Now what we're going to do is the second part. We're going to split the bx part. We're going to split this part up, and we're going to split it up into these numbers, and then we'll do some factorizing using the earlier techniques. So I'm going to split the 11x up, and I'm going to use these two numbers to help me. In fact, I'm going to do it over here to show you that there's two ways you can do it. I could split it as a 3x and an 8x, or I could have split it as an 8x and a 3x. And I'm going to show you that both of these will give you the same result in just a second. Then it says, factorize using earlier technique. Well, what I'm going to do here, this needs a lot more explanation. I'm going to factorize these two parts separately. I'm going to factorize this, and then I'm going to factorize this, and then I'll see if I can combine them together. So when I factorize the first part, I'm going to take out an x, and I get a 2x plus 3. And when I factorize this part, I have a positive 8x and a positive 12. I'm going to take out a factor of a positive 4, and that gives me a 2x plus 3. Now we're going to try and factorize using an earlier technique. This is really similar to what we were just doing on this page that we've got here. So I'm going to say that they both have got a 2x plus 3. This part needs to be multiplied by an x, and this part needs to be multiplied by a plus 4. So it factorizes to 2x plus 3x plus 4. 2x plus 3, x plus 4. It does factorize to that. Now, if you don't like this bit of like, how does this go to this? You can just see you've got a 2x plus 3 and the x plus 4 comes from the bits that go in front of those brackets. Now, what would have happened if we split it in a different way? Well, let's just see what happens. So I'm going to take out of this first part. I just want to make this a different color so that it doesn't look like part of the question. Let's just do it as purple. I'm going to factorize that first button. They always take out the highest common factor. They have a 2x in common. That would be an x plus 4. Now for the next section, they just have a 3 in common. So that would be x plus 4. Look, you have to have this repeating. If it doesn't repeat, something's gone wrong. There's an x plus 4 and an x plus 4. So when I take out the x plus 4, for the first one I need a 2x, and for the second one I need a 3. So you've got the same thing, but just the other way around. It's exactly the same answer. Okay, I'm only going to do this in one way. I'm not going to do both ways, but it will always work. So the AC that we have in this case is going to be the 2 multiplied by the minus 18. That's minus 36. A is just the number we refer to in front of this. This is the B number, and this is the C number. So I'm thinking of two numbers that multiply to negative 36, but they need to add to 9. So 36, I guess we've got 1 and 36, or 2 and 18, 3 and 12. If I did them, one of these negative, I think I could get the 9. So I think if I make that one negative, this is the one that I want to use. I want to use negative 3 and 12. And you can split that up, because 9 I could rewrite as 12x minus 3x. So we get 2x squared plus 12x minus 3x minus 18. This is exactly the same as, I haven't changed anything. 9 is the same as 12 minus 3. Now I'm going to factorize this beginning part. In this beginning part that we've got here, I have a 2x as the highest common factor, which is going to be x plus 6. Now I need the second bracket to have an x plus 6 in, so I'm actually going to take out a negative 3 this time, and it will be an x plus 6, because negative 3 times x is negative 3x, and negative 3 times positive 6 is negative 18. That's probably the hardest part that we've done so far, but I had to have a matching x plus 6 in both of these brackets. So when I take the x plus 6 out, I get 2x for the first bracket and minus 3 for the second bracket. So this factorizes to this. Okay, let's try this one. This is much harder. You won't be able to do this through recognition. You're going to have to use the AC method. So AC for this, AC is going to be minus 60, and I want them to add to minus 17. So minus 60, remember I'm going to decide which is negative afterwards. It could be 1 and 60, that's not going to work. It could be 2 and 30, that's not going to work. 3 and 20. Ooh, 3 and 20. If I make one of those negative, I can get to minus 17. I'm going to make that one negative. So this is the one I'm going to use to split it up. It's going to be 12x squared minus, I'll do plus 3x, minus 20x, minus 5. So that has split into these two. That's perfectly fine to do. Now I'm going to take out the highest common factor of these first two. That is going to be 3x brackets 4x plus 1. Remembering I'm wanting this bracket to be another 4x plus 1. So it looks like if I take it minus 5 out, I would get minus 20 and minus 5. Perfect. So I've got these matching brackets here. That means I can just say my first bracket is 4x plus 1, and my second bracket is 3x minus 5. I'm not going to do it, but you could expand this, and you'd get the same as this one. Okay, so you could try and do the guessing technique with these, but there's so many things you could have in the beginning. You could have had 2 and 6, or you could have had x and 12x, or 3x and 4x the other way around. It's just so confusing. So I think this AC method is the best. So in this case, our AC is going to be the 6 and the minus 15. 6 times 15 is 90. So I need it to be minus 90, but I want it to add to 1. Well, 1 and 90 is not going to be good. 2 and 45 is not going to be good. Oh, I think I'm spotting what it's going to be in a second. 3 and 30, 5. I actually just think I know it's going to be 9 and 10. 9 times 10 gives you something to do with 90, but I want one of them to be negative and for it to add to 1. So I'm going to make that one negative, because 10 take away 9 is 1. That means I can now split up the middle. So I'm going to say that it is going to be a plus 10x. I'll do it the other way around just to show you it still works. I'll do minus 9x plus 10x minus 15. factorise the first section. So that's 3x brackets 2x minus 3. Remember, you're going to want a 2x minus 3 in the second bracket, and so I'm going to put a 5. That will work. That means that I have 2x minus 3 for the first bracket, and then 3x plus 5 for the second bracket. Really difficult questions here. So your turn. You're only going to do 4 because they're quite challenging, but there are more of them linked in the description. Okay, so this first one I think I can just do by recognition because this is a really easy number and so is this. So I think I can just say that we're going to have definitely a 2x and an x. And to get the 7, if I put the 3 here and the 1 here, I would get the 2x and the 3 would give me 6x. And then I would get the extra 1x from here that I needed. So that one I can just do from recognition. But this one, you know what? I'll do the AC method. So the AC is going to be minus 100. But I want them to add to 15. So for minus 100, I guess I could do, I don't know, 10 times 10, that wouldn't work. I could do 20 times 5. Yep, this is going to be it. 20 and 5. If I make one of them negative, this one, they would add to negative 15. So I want to do the 20 and the minus 5. So I should always have an equals at the beginning. I've not been very good at doing that. I'm going to do 2x squared. I can do the minus 5 if I want first. I could do minus 5x plus 20x minus 50. I'm going to factorise that first section that I've got there, which gives me x brackets 2x minus 5. I'm going to definitely want that in the next part. The highest common factor here looks like a 10, and that would be 2x minus 5 in the brackets. Great, we've got the matching brackets. If you don't get the matching brackets, something has broken. You've done something wrong. So it's 2x minus 5, x plus 10. You can expand and check and see if you're right. Okay, I am definitely going to do the AC method for this. So the AC method is going to be 4 times 27. That is 4 times 20 is 80 and 4 times 7 is 28. So that's going to be minus 108. Whew. So I need to think of two things that multiply to negative 108 but add to minus 12. Let's be systematic. So 1 and 108, that's not going to work. 2 and 54, that's not going to work. 3 and what's that going to be? 36. That wouldn't work if I made one of them negative. 4 times by 27, that's not going to work. 5 doesn't go in. What about 6? 6 goes into 108. 6 and 8, not 6 and 8, 6 and 18, 60, 6 and 18. I actually think 6 and 18 is going to be the one that will give me something to do with 12. Let's just double check that 6 times 18 is 108. Yep, good. So if I want to make one of them negative, I think I'm going to need to make the 18 negative for this to work. So I'm going to do 4x squared plus 6x minus 18x minus 27. I split the minus 12 into this. It's definitely still true. Okay, factorising the beginning part, 2x brackets 2x plus 3. Factorising the next part, so there's definitely a 2x plus 3 there. I think it needs to be multiplied by a minus 9 outside the front, minus 9. Minus 9 times 2x, yep, minus 9 times 3, yep, that works. So my final answer is 2x plus 3, 2x minus 9. That's going to give me the 27, that's going to give me the 4x squared, 6x minus 18x. Yep, it works. Okay, last one, we'll do the AC technique. I think question 3 was definitely the hardest. AC is minus 12. I've picked some really horrible answers for us to do here. So minus 12, we think of two numbers. I guess we could have 1 and 12. We could have 2 and 6 or 3 and 4, and we want them to add to 1, making one of them negative. I think if we make that one negative, it will be this one here. So it's going to be 6x squared minus 3x plus 4x minus 2. Factorising the first half of that question, you get 3x brackets 2x minus 1. And then taking a 2 out of this bracket, you get 2x minus 1. Luckily, we've got, like we did in the previous one, matching brackets, which means we can do the final step of factorising, which is 2x minus 1, 3x plus 2. Super challenging, these questions. Really difficult. They require a lot of practice, and they are very useful if you're going to be doing A-level maths. They love doing these questions towards the end of a GCSE paper as well. So definitely worth spending some time practicing. Like I said, there's questions that are linked in the description. Last video of the playlist is going to be combining factorising techniques, but I think this is definitely one of the hardest things in GCSE, so make sure you are practicing it a lot. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.